Hello, folks. I'm Rod Machado. Thank you so much for attending my Aviation Learning Center. Are you someone who thinks that maneuvering speed determines how well things go on a first date? Well, that's not the kind of maneuvering speed I'm talking about here. Instead, I'm talking about your airplane's maneuvering speed, or VA, and how it is determined. For the sake of definition, let's be clear that maneuvering speed is the speed at which the airplane will stall before exceeding its limit load factor should the angle of attack suddenly and dramatically increase. Given that, let's assume that you're standing anywhere on planet Earth. If so, you'll experience 1 times the force of gravity, or 1g. And it's gravity that pulls you toward the center of the Earth, giving you that feeling that you've come to know as weight. When an airplane experiences a sudden increase in angle of attack, however, you and the airplane can feel like you actually weigh more than 1g. And this apparent weight increase is called an increase in G-force, or load factor. So let's assume our airplane is in cruising straight and level flight at a constant airspeed. In this condition, lift is equal to weight, and we experience 1g, or a G-force of 1. And we can represent G-force by the following formula. Yes, I understand that 5 out of 4 people have trouble with math, but this is the only formula you'll need here, I promise. The ratio of lift to weight equals the G-force you experience. In straight and level unaccelerated flight, the lift developed by the wings is equal to the airplane's weight. Thus, the airplane experiences a G-force of 1g. If the angle of attack suddenly increased by pulling back on the elevator control or encountering a strong vertical gust of wind, for example, the wings would produce an instantaneous increase in lift. The airplane would accelerate upward, and you, my friend, would be forced downward in your seat. Said another way, there would be more upward pull of lift compared to the downward pull of weight, and the G-force you would now be experiencing increases in proportion to the sudden increase in lift. Instantaneously doubling, tripling, or quadrupling the lift doubles, triples, or quadruples the G-force. In other words, a direct, or nearly so, one-to-one relationship exists between lift and angle of attack. Let's assume our airplane is flying at a cruise speed of 140 knots, a relatively fast cruise speed. The airplane and its contents experience 1g at an angle of attack of 3 degrees for level flight in this condition at this speed. Suppose a sudden gust increased the angle of attack by an additional 3 degrees. Now the wing's original angle of attack has doubled to 6 degrees. Consequently, lift suddenly doubles, producing 2g's. A sudden increase in angle of attack to 9 degrees triples the lift and the G-force. An increase to 12, 15, and 18 degrees increases the lift and G-force to 4, 5, and 6 times its original value. Since wings stall at an angle of attack of approximately 18 degrees, any further increase in angle of attack beyond 6 times the original value of 3 degrees won't increase the G-force. After all, stalled wings aren't producing very much lift. Therefore, at 140 knots, our airplane is capable of experiencing a maximum of 6 Gs before the wings stall. Now, if our airplane had a limit load factor of 4 Gs, the airplane structure might experience some damage at this speed in strong turbulence. Now, I chose 4 Gs instead of the actual limit loads of 3.8 Gs, positive 3.8 Gs for standard airplane certification, to simplify the math. 5 out of 4, remember? Now, watch what happens if we slow our airplane down to 110 knots. At 110 knots, a 4.5 degree angle of attack is necessary for a 1G level flight condition. If at 110 knots we suddenly double the original angle of attack to 9 degrees, then lift doubles. We are now feeling 2 Gs. A sudden tripling of the original angle of attack to 13.5 degrees triples the lift, and we experience 3 Gs. And finally, quadrupling the original angle of attack to 18 degrees produces 4 times as much lift. Therefore, we experience 4 Gs. Now, here's the payoff for you. It's not possible to pull more than 4 Gs at 110 knots in this example since the wings will stall at 18 degrees. Consequently, 110 knots is the maneuvering speed for our airplane if we don't want to experience more than 4 Gs before the wings stall. At 110 knots, the airplane will stall before it exceeds this limit load factor in turbulent air or with full deflection of the elevator control. Personally, in turbulence, my preference is to fly at 10 to 15 knots below maneuvering speed to prevent a gust from temporarily raising my indicated airspeed above maneuvering speed. Additionally, the use of power actually reduces the airplane's stall speed. Therefore, the maneuvering speed is a little slower. Not much, but a little. Now, here is where I want you to put your finger in your ear. Go ahead, do it. And the reason I want you to do that is that what I'm going to say is so important, I don't want it to go in one ear and out the other. Whether a specific gust doubles, triples, or quadruples the angle of attack depends on the angle of attack of the airplane in its 1G condition. As is clearly evident from these examples, it's easier for a gust to double, triple, or quadruple the angle of attack over its starting value when the airplane is flying faster because it's at a lower angle of attack to begin with. Consequently, it's easier to experience more Gs for a given amount of turbulence at higher airspeeds. So there you have it, a graphic and non-technical understanding of maneuvering speed. Now, I hope this helps you understand the concept of maneuvering speed a little bit better. In our next video, we'll talk about how maneuvering speed varies with weight. And if you'd like to read more about these and other concepts, then pick up a copy of my private pilot handbook. It's all in there. So thank you so much for attending my Aviation Learning Center. I've been Rod Machado, and one more thing. It's going to be a lot easier for you to wear your headset if you take your finger out of your ear now.